All right, it looks like we might be live. There we are. All right. Welcome, everybody. You're in the right place if you're here for the free live lesson on pre-algebra. Today, we're going to be learning about the power of estimation. If you can hear me, please put a plus in the chat so I know that I'm not just talking to myself here. I know there were a couple of you waiting. Thank you for being early and on time on the 1st of October. Can you believe we only have 3 months left of 2025? It's absolutely nuts. We have 3 months left of 2025. That's so crazy. Like it's gonna be Halloween soon, and then Thanksgiving, and then Christmas, and then we blink, and it's gonna be 2026. It's so wild that that's the case. But anyway, you're in the right place if you're here for pre-algebra free live lesson on estimation. You can access the workbook in the video description down below. It should be that very first link. And every lesson comes with a workbook like that, professionally designed. So all you have to do is focus on the learning and don't have to focus on copying things down as we move along. All right. Before we get started, if you can copy that link in the browser, in your browser, at the top of your browser, copy that link, share with a friend, share with a family member, share with anyone who you think would benefit from today's lesson. And let's get started. All right. A little bit about me. I'm Eddie Kang. I'm the senior math teacher at my EdSpace. I've been teaching for 9 years now in high schools and colleges. I private tutored every grade level from 6th grade all the way to students preparing for graduate school. I did really well in school myself. I did really well in all my math classes. Got a perfect score on the SAT and eventually got into my dream school at UCLA. After I graduated from UCLA with a degree in pure mathematics, I decided to become a math teacher and quickly found I was so passionate about teaching math. It showed because my students have gotten to the top universities in the nation. They've gotten perfect scores on their SAT scores, on their SATs, 5s on their AP exams, performed above the national average on almost every metric you could think of. And yeah, most importantly though, they had fun doing it. And that's what we're here for today. We're here to have fun. We're here to have a good time. And that's what we are here for today. If you don't know how to chat, you might have to subscribe to my channel first so that you can chat in the live chat today. That'll give you the optimal experience of what it would be like to be a part of my course. So please make sure to do that. Obviously, if you did not enjoy today's live lesson at the end of today's lesson, you can always unsubscribe. But in order to get the full experience of what it's like to be in one of my courses or in one of my lessons, please subscribe so that you can chat. And once you can chat, everything will become so much more interactive and engaging. Let's get started. So a quick vibe check. I like to start off my lessons with a vibe check because I know right now it's 5 p.m. on the West Coast, but on the East Coast, it is 8 p.m. So many of you might be really tired after dinner or ready to go to bed after this lesson, whatever it may be. We're trying to get our brains activated again, get our gears running again. And that's why we have this vibe check. Why do we estimate? That's our very first question today. Why do we estimate? Why do we estimate? Well, we estimate. The main reason is to save time. Exact calculations can take a long time, but estimation is quick and gives us a fast idea of the answer. For example, in 2022, roughly 1,526 flights landed and took off from LAX per day. LAX is the airport in Los Angeles, where I am based. Estimate the total number of aircraft operations at LAX in 2022. All right, in 2022 means within the entire year. In a year, there are 365 days. And we know that roughly, so this is also an estimate, roughly 1,526 flights landed and took off from LAX per day. So what we're trying to estimate here is 1,526 times 365. Now, I can see a lot of you pulling out your calculators or trying to figure out the fastest way to do this. Well, I can assure you that if you were to estimate 1,500 for 1,526 and 400 for 365, This gives us 600,000, and that's our estimate. And that was probably going to be way faster than you taking out your calculator and plugging in these numbers. This becomes especially more powerful when we have more complex expressions where there may be squares, square roots, divisions, multiplications, parentheses, and it takes a lot longer to input those into a calculator. But now using something like this, it becomes a lot easier. So let's see the actual number of flights in 2022. And that was 556,000, and that would round up to 600,000 to one significant digit. So I'd say that's a pretty good estimate, pretty accurate if you ask me, especially because even this estimate of flights landed and took off is also an estimate. Okay, let's take a look at rounding. You're at the local supermarket with $25. Your basket has items priced as such. Do you need to calculate the exact total, or will an estimate be good enough to check if you have enough money? Let me know in the chat, what do you think is the best way to go here? Do you need to calculate the exact total, or will an estimate be good enough to check? Let me know in the chat. The exact total, I would probably want to take out my calculator. There are so many decimals in place here. But with an estimate, it might be a little bit easier, right? And when we estimate, especially with money, let's always round up. So $3.99, I'm going to call that $4. $2.79, I'll call that $3. $4.49, I'll call that, let's just call it $5. Why not? And $8.50, let's call it $9. Now we add all this up. 4 plus 3 is 7, plus 5 is 12, plus a 9 is $21. Now, if we have $25, $21 is obviously affordable with the $25 we have. So it makes sense that in this case, we would estimate instead of trying to, plug all this into a calculator while waiting in line, or maybe in one of the aisles, deciding whether I can buy one more item, right? Things like that. Estimation is a powerful tool that gets us to some answers more quickly and often very accurately as well. Now, this next question. An engineer is calculating the weight a bridge can safely hold. Cars and buses have different weights, and the bridge needs to support many vehicles at once. Should the engineer estimate or calculate exactly? Well, let's take a look. An engineer is calculating the weight a bridge can safely hold. Cars and buses. Now, cars and buses have different weights, so we'll never know whether how many cars there are on the bridge or how many buses there are on the bridge. We won't know. So in this case, the engineer should estimate because it's almost impossible to calculate exactly. We would estimate and we would round up, right? We would round up. If you've ever been in an elevator, you may have seen the max capacity. Let's say it was like 1,000 pounds. Often, I think it's 10,000 pounds. But do you really think once it gets to 10,000 pounds, the elevator is going to shut down? Highly unlikely. What they probably do here is that the actual number is probably around 15,000 to 20,000, but they keep it at 10,000 on the placard so that people know, like, don't try to fill it up past this amount, right? I'd say the average person in America probably weighs between 150 to 200 pounds. So roughly, that would be about 50 people, and I don't think you could fit 50 people in an elevator anyway. But yeah, we would estimate here. Let's take a look at these. Here's another opportunity for you to participate. To estimate approximate answers to a calculation, we round our figures to one significant figure. It isn't an exact answer, but as we have seen, the solutions are close. Scary close, like our LAX question earlier. Approximate each of the following. So A says 49 times 82. What number should we estimate 49 to? And what number do you think estimating 82 to would benefit us in calculating this much more quickly than if we were to plug this into a calculator or actually do the multiplication out? 82 times 49, right? 82 times the 9 and then 82 times the 40. Add them up. Highly likely to create a mistake along the way. slightly time consuming as well. But what numbers would you want to estimate these two numbers to? 49 and 82 in the chat. Let me know. We have 49, 50, right? Very close number to 49. And for 82, 80 is a very close number. So 8 times 4 is 40, and we tack on the remaining zeros. 0, 0. So 4,000 is our estimate or approximation for 49 times 82. I believe the actual answer to this is 4,018 or something like that. Yeah, we got super close, super close just by estimating. So for letter B, what would you do here? What would you approximate 398 to? What would you approximate 612 to? And what would you approximate 203 to? Let me know in the chat. What would you approximate each of these to? 398, 612, and 203. We're working with 3-digit numbers now, not just 2 digits. But there are some easy things to do here. 398, very close to 400. 612, very close to 600. And 203, very close to 200. This is equal to 1,200, and there we go. That's our approximation for this. And notice how I'm using squigglies, right? I'm using squigglies to notate that I am approximating these values. So 2,981, that will estimate to 3,000, and 49 to 50. These cancel, leaving us with just 60. So that is our approximation for letter C. Hopefully you're sticking along here. Again, if you're afraid of making mistakes, don't be, because whenever you make a mistake and you fix that mistake, brain research shows that when you fix a mistake, that's when true learning occurs, and that's when true retention occurs. If you're not making any mistakes, high chance that you're not going to remember it. You're not really learning. You're just passively going about your day. Another thing is that asking questions proves that you are actively thinking and actively learning and participating in the act of learning. So ask questions whenever anything pops up. That's the great thing about these live lessons. You get to ask questions in the live chat. I'm constantly reading it. So if you, let's say you ask a question and it's been like 30 seconds, I might get to it by then, and then I'll answer that question, right? So you'll never have to raise your hand or anything. All you have to do is just plug it right into the live chat, and I'll see it. That's the great thing about these live lessons. No student left behind, truly. Here's letter A. Approximate each of the following. Ooh, now we have some more complex things going on here, like I was saying earlier. A lot tougher to plug these into a calculator, and this is where estimation becomes so much more powerful. Here we have 9.9%. Well, 9.9% we can estimate to 10%. Of 5,987, we can say that's 6,000. 10% of 6,000 is 600. So we can say this is approximately 600. Very cool. Now, for the next one, what would you do here? This one is a little bit more interesting. 31.2 and 68.8. If you add those up, that's actually 100. But 31.2 is very close to 30. And 68.8 is really close to 70. 4.13 really close to 4, and 2.12 really close to 2. So now we have the square root of 100 over 4 divided by 2, which is 2. Now let me know if you know in the chat, what is the square root of 100? That's basically asking us what number squared. What number times itself gives us 100. That's basically what a square root is asking us to do. And that will be 10 over 2. That's equal to 5. So my approximation for this really kind of gross looking expression here is 5. That simple. Letter C might be even more simple than these previous two, because 9.9 we know rounds to 10, and 10 squared is 100. So I'm going to say this is roughly 100. I believe the actual answer to this is 98 point something. So really, really close to 100 as well. All right, let's keep it moving. If we don't have any questions or any participants, I mean, today might go so quickly, right? Whenever I plan a lesson, I always expect multiple responses, for a lot of you to make mistakes along the way, because I'm expecting that this is the first time you're seeing this. So I don't expect you to get things right away, obviously. So whenever I'm going from slide to slide, yes, I'm ramping up the level as we go through the lesson, but I'm making sure along the way that every student, everyone in here is getting it as we move along. So students are asking questions. Students are participating, making mistakes, fixing their mistakes in the chat. Be like, oh, sorry, typo. Or, oh, sorry, I forgot to do that. Oh, sorry, it should say x equals. Oh, sorry, I forgot units of measure. Things like that. And you're fixing these mistakes during the lesson so that after the lesson, when you look at the practice problems that I provide after every lesson, that's another opportunity to check for your understanding and achieve mastery on that concept or skill. And after that, I also provide video solutions on those practice problems. So it's basically another lesson in and of itself so that you truly master it before you enter my next lesson, in our next lesson in the course, so you're up to speed on everything. Let's check this out. So A, estimate these roots to 1 decimal place. All right, so we have the square root of 3. What numbers do you know that are really close to 3 that we can take the square root of? Let me know in the chat. What numbers do you know really close to 3 that we can take the square root of and get a whole number? Really close to 3. Maybe one more than 3. We have a 4, right? A radical 4. And then below the 3, we have a 1. So radical 1 is 1. Radical 4 is 2. So however we're estimating radical 3 is going to be approximately 1 point something. Now let me show you my logic for this. Between 1 and 3, they are 2 apart. Between 3 and 4, they are 1 apart. So 2 and 1, I recognize that those numbers are really small. So let me rewrite those. 2 apart, 1 apart. Total from 1 to 4, that's 3 apart. If you take 2 out of that 3, that's approximately 0.67. Well, 0.67 rounds up to 7, and we're asked for 1 decimal place. So 1.7 will be our estimation for radical 3. Let's try the same thing with the square root of 75. What are some numbers around 75 that we know are perfect squares? Around 75, what are some numbers that we know that are perfect squares? 75. There's nothing in the 70s, but in the 80s, 81, right? 81, the square root of 81 is 9, okay? So then now on the other side of 75, we have 60s. 61, 62, 63, 64, right? 64. Great. 64, the square root of 64 is 8. So I know that the square root of 75 is going to be 8 point something. Now, using the same logic that we did prior, we have 11 between 64 and 75, and we have 6 in between 75 and 81. So between 64 and 81, that's 17 total. So 11 out of 17. That's very similar to 12 over 18, which is equal to 2 over 3, which is approximately 0.67, which rounds up to 0.7. I can guarantee you that if you plugged radical 3 into your calculator and radical 75 into your calculator, and you round to 1 decimal place, you will get these numbers, which is absolutely insane that we can just estimate like this square roots, right? We're working with square roots here, and we could just estimate it like this and get as close as a calculator could, right? That's pretty amazing. This is a really powerful tool, and this is going to boost your math sense, boost your mental math skills, and make those little arithmetic steps later on when you get into algebra 1, geometry, algebra 2, pre-calculus, even calculus. It'll help you make sense of the problem just by knowing how to estimate random numbers like this, right? 75 is a pretty random number, right? But taking the square root of that random number, we just estimated it to one decimal place without using a calculator, which is pretty wild. All right. Let's take a look at these. Dividing by numbers less than 1. What would you estimate these numbers to? 20.45 and 0.49. What would you do here? In the chat, let me know. Approximate each of the following. $20.45 can estimate to 20, and 0.49 can estimate to 0.5. Okay, so 20 divided by 0.5, 0.5 is 1/2, and we have 20 times 2 over 1, that's equivalent to 40. Okay. Then, letter B. 52, that can be estimated to 50. 6.78, that could be estimated to 7. 0.51, that could be estimated to 0.5. Now, 50 times 7 is 350. 0.5 is 1/2, so whenever we divide by a number, we can multiply by its reciprocal. So that'll be 700. So right now, we just found approximations here. I don't know why I said it like that. Approximations is 700. And now let's check out letter C. 4.8, I can round to 5. So we have 5 squared times 11.3. We know what 11 squared is, so let's use 11 instead of rounding all the way down to 10. On the bottom, 3.28 minus 3.12. Let's actually solve for that because that's actually easy to do. We get 0.16. So now on the bottom, 0.16 can be estimated to 0.2. 5 squared is 25. Now 11 squared is 121. But I'm going to estimate that to 120. That's why I put this squiggly here for the 120 and the 0.2. 25 times 12 is 300. So we have 3,000 up here. Oh, let me make sure real quick. Yes, that's correct. All over 0.2. Now 0.2 is the same as 1/5 or 2/10. So when I divide by 1/5, I can multiply by 5 over 1. And that will give me 15,000. And that will be quite the accurate estimation or approximation to this huge fraction that we see here. All right, I'm going to pause here for any questions. I see about just 3 of us today. All good. Any questions? Any questions that we have or any comments before we move on to the last couple problems for today? We just flew by today because, I mean, it feels like everyone's getting it. No questions. All right. Let's keep it going then. Feel free to say hi to let me know you're here so I know I'm not alone because I see that there are a couple of us in the chat or at least on the stream watching. Feel free to say hi. I don't bite. Would love to interact with you on the other side of this screen as well. All right, let's take a look at this practice problem. Penny has worked out this on her calculator, and her answer was 13,332, blah, blah, blah. Penny's answer is not sensible. So what they're telling us right now is that Penny's answer is wrong for sure. By rounding each number to one significant figure, work out a sensible estimate to show that her answer is not sensible. All right, we're going to keep doing what we've been doing. 81.2, I'm going to estimate to 80. 59.2, I will estimate to 60. And 1.9, I'll estimate to 2. So if we solve this, 8 times 6 is 48. Tack on the 2 zeros, and now I have 4. That's equal to 1,200. Wow, that is not even close to this number. This says 13,000. Here I have 1,200. That's an insane discrepancy, and that's how we can prove that Penny's answer is not sensible. Okay. Here is our last question for today. We absolutely just zoomed through today's lesson. I mean, largely because, very few participants, but hopefully you learned something new today. Let's take a look at this application. For a baseball game, there are 19,763 tickets sold for $93 each. 26,235 tickets were sold for $207 each. Work out an estimate for the total amount of money paid for these tickets. Okay, let's take a look at this number first, 19,763. What could I estimate that to? I noticed that 19,000, I could possibly do it to that, but I see the 7, and that should round us up to that next number, right? To the next number in the thousands, right? The 7 is pretty close to the next number. So instead of 19,000, maybe I say 20,000. How about the $93 each? I can estimate that to an easier number like 100. Let's do the other numbers while we're at it. 26,235. What could I estimate that to? Maybe 26,000? But I don't know how I feel about the 26, but I mean, we'll keep it there. 207. We could also estimate it to 25,000 because 25 is much easier to work with than 26. Let's see what we get here. 207. Yeah, we could do 210, but I'd much rather use 200, right? So you see the flexibility that we have here. The flexibility is that, again, we're just estimating, right? We are just estimating. So we don't have to be as exact as we need to be. As long as we're estimating close enough, our final estimation should be very close to the actual total amount of money paid for these tickets. So let's take a look at that. We have 20,000 times 100. That's equal to, we have 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. That's 2 million. Let me redraw that comma because right now it looks like something else. $2 million for these first batch of tickets. Second, we have 25,000 times 200. So 2 times 25 is 50, and we have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. That is $5 million. So my approximation for the total amount of money paid for all of these tickets is $7 million, which is a lot of money paid for these tickets. Now I'd be curious how much it takes to actually rent the stadium or have that space, including the parking space and everything around it. It must cost a fortune, but $7 million for one game is quite the money, right? It's quite the money, but in relation to everything else, might not be that much. But this is the power of estimation, y'all, right? So powerful, such a powerful tool to get to your final answer quickly and semi-accurately as well. All right, if you enjoyed the lesson, call your parents right now. Our lesson may be ending, but your progress doesn't have to. At my Space, my pre-algebra full year course starts on Monday, October 6th. I know we have a list of students already registered. I'm so excited to teach you guys once you guys join. I know some of you may be here today. So excited to get into my full curriculum and get you to where you want to be and maybe even further than what you think you're capable of. And that is my goal. Each course includes 2 engaging live and interactive lessons like you just saw today, 2 of them a week. Every lesson is recorded just in case you have some family event or extracurricular activity and you can't make a lesson. All good. You can revisit that lesson and review it through the recording at any time until June of 2026. Professionally designed workbooks come with every lesson so that you can follow along and you don't have to worry about copying down shapes or graphs or anything like that. And after every lesson, this is one of the best parts. You get practice problems with exam style questions, only 5 of them per lesson. So I'm not trying to, shove this down your throat. I'm not trying to cram it. I'm trying to get you these 5 questions after each lesson, exam style questions that are challenging, but not too challenging, that you should be able to access after that respective lesson. I don't leave you hanging as well. As I said before, I make detailed video solutions on every single practice problem. So let's say after you submit the practice problems, you got maybe number 4 wrong. You can go to the video solution, click on Q4, question 4, and it'll take you right to my video explanation of that problem. And this is a huge highlight of my course. But how much is it? For context, when I used to be a private tutor, I started tutoring when I was in high school. I did it for pro bono, which means for the public good, basically volunteer work. And the most I could really do is just homework help, right? I'm not really teaching other students anything. I'm just helping them with their homework, younger students at younger grade levels. When I got into college, I was charging about $30 to $40 an hour because now I'm at UCLA. I'm a math major. I know basically all of high school math, so I can afford to charge that much. But again, still homework help, maybe some exam review help, but nothing really getting them prepared for the following lesson or anything like that because I don't know what the teacher is going to be doing. But now, 5, 6, 7, 8, now at 9+ years teaching in high schools and colleges and having private tutored every grade level from 6th grade all the way to students preparing for graduate school, I used to charge a minimum of $100 per hour to $200. And that's the problem. Families have to choose between what works and what they can afford, what's effective versus what's affordable. And you can never get both until now. And that's why we created My EdSpace. You get all of this for just $99 a month, which is 8 times cheaper than if you had me as a private tutor or any tutor, as a matter of fact. $99 a month, that means 2 engaging live lessons per week. That's 8 lessons per month. And you're getting it for $99 a month. Some tutors charge $99 for an hour, right? Insane value. And this is why we created My EdSpace, to make expert math education and math teaching accessible and affordable for everyone across the nation and eventually globally. And why stop there? I'm offering a 20% additional discount on our annual package if you're interested in purchasing the entire year course. To protect you from any risk as well, we provide a 30-day risk-free full refund guarantee. If you go through the first 8 lessons in the first month, basically the first 30 days, and you don't like it, full refund automatically, right? And this is kind of my way of telling you that this is how confident I am that the value that you're getting out of this is going to be amazing. It is a first come first serve basis, so this is a limited time offer. So if you are interested, text me code word start to my number 512-900-1283 or scan this QR code. It should prompt you to send that code word straight to that number right away. I'll host a quick little Q&A as well since we ended so early. But if you don't have any more questions, thank you for joining today. Enjoy your evening, and I will see you at course start on Monday. Looking forward to seeing you there. Oh, let me go back to the previous slide. All right, everybody. Thank you for your time. If you're still typing here, go ahead, send that message. But if not, enjoy the rest of your evenings. Enjoy your weekend, and I will see you on Monday at course start.